Correct. Today we'll discuss a regression model deployment in local machine and Docker basics. If you're using Windows, you need to download Docker Desktop. Search for Docker Desktop, click on this one, and you have download for Windows, right? Just click on this. This will download an exe. So this is going to be like this. Install with default values. So not to change anything. Just next, next, next. Nothing fancy. Just restart the machine after you install it. Okay, so once you install it, so again search for Docker Desktop, open it. This will open a window and make sure that the engine is running. By default, it's not going to be in stop mode. Make sure that it's going to be in. So you'll get a window like this to install things. But in my case, it's already up to date, so I'm not going to install it. So restart the machine after the installation and open Docker Desktop. Open and then make sure that the engine is running. This will make sure that the Docker is running, right? And thereafter follow
What
the.
if it is stopped? How to make it run?
Yeah, you have that option over there itself. Right?
A play and pause button. That's it.
Yeah, play and pause. It will automatically starts. So go. Set. So these steps basically for Linux one. So you not to worry about it. Just cross check with the Docker help open terminal Docker version. You see that it has been installed, right? Help will give you the list of commands that Docker supports. So we are in, I'm going to open a terminal here. Or maybe somewhere else. Yeah, Docker test. Okay, now there are multiple ways to have a Docker. Basically, initially, this containerization or containers, we call it as. It initially started in Linux. Then Docker organization, Docker company, what they did is they brought this concept of containers to almost all the operating systems, Mac, of course, Linux. So the common, so by installing this Docker, it will install all the binaries that will make sure that we can run the containers. The idea of containers is, let's take that you hear this issue quite frequently in IT industry, but something that it worked in one machine, system one, in system two, when we move, all the software over there, so it stopped working, right? Something that worked in one machine but didn't work in another machine. Even if I provide files to you, someone will complain that it worked in your machine but it didn't work in my machine. It is throwing error, kind of. So what we call it as compatibility issues, right? Compatibility issues in terms of system. So when we say compatibility issues or like any errors we get, there are two kinds of errors, right? Two kinds of issues. One, OS package or software dependencies. Another one is application or software dependencies. When I say library or whatever, application of software dependency. So it can be application related. Let's take Docker. Docker is an application. It may have some dependencies. On OS related, so Windows or Linux or Mac, whatever. So it will have its own package, something that it's been there in a certain OS, even though it's the same OS, Linux and Linux, CentOS and CentOS. Something that I install in one machine may not be there in other. So how do we solve this problem? So we solve this with containers. How does it solve? It's going to, like every container is going to have mini OS, mini Linux OS, plus application dependencies. For example, let me show you a practical. So here, if you open terminal, if you look at this one, we have Docker file. This we call it as image file, right? So you can see that I have installed all the OS related packages or the stuff. Even if you look at this one, I made sure that all the OS related stuff I have installed it. Apart from it, I'm trying to install application dependencies also. So I have something, I need Python libraries to execute this one. So I'm executing requirements.txt file. Requirements.txt file is list of libraries, what is required for this Python application. This is a Flask application. This requires 2 libraries, and this I have listed it here. Okay. Now we have a mini Linux OS plus OS packages plus application libraries. Now, dependency in the sense libraries. Everything being packed. So now, if everything been carried to any system we want, then there is no compatibility issue, right? So it is going to be consistent across all, irrespective of the system that we carry. That's exactly what this Docker or the containerization, solution solve. Like is going to address. It is going to help us in giving a consistent environment, because it will have a mini Linux OS, so it does not depend on the host OS. So there is no OS related issues. Even if I need additional OS packages and is going to install on my own using this Docker file, I'm going to include everything here. This is going to be a mini OS. This has Anaconda pre-installed in it. So it's actually, this one is actually a mini Linux OS. Linux OS plus Anaconda installed in it. Where do we get this, these sort of images? We get it in Docker Hub. We go to Docker Hub, click on this, search for this one. Let's take Anaconda. It's going to list out all the packages. So more consistent one is the continuum. So you can see this continuum. We need to, in tanks, you'll find multiple versions. You can see multiple versions. So you need to specify the version. Otherwise, what happens is, like, when we don't mention the version, in future, right now it may work, but in future, this may not work, because when the version changes, there's a possibility that the previous functions or methods or properties doesn't work. So you need to mention the version. Even in this case, I have clearly mentioned the version. Apart from it, I have mentioned requirements.txt file, Python versions. You need to specifically mention all the versions. Yeah, how do we know that? Again, we need to cross-check it. We need to test and find out which version will work, right? So when you want to run a container in your local machine, one, you can directly pull an image. You can see there is a pull command. Everywhere you can see that pull command. You can run a pull command, or there is an alternative for this one. Here is that, yeah. There is an alternative method that you can build your own image by including Docker file. This has to be capital D and the remaining letter should be small case. There is no space between Docker and file. Okay. So you need to include in it. Again, if you look at this Docker file itself, we are using HTTP. HTTP is basically a mini Linux OS plus HTTP package is pre-installed in it. So we are internally using this Docker image, plus we are adding our own thing stuff. Even if we build our own image, we are in fact getting a package from here and we are adding our own stuff. So this is going to be our own Docker image then. On top of this, we're going to create containers. So we'll see how to create a container. Okay. So we will, first of all, we will see how to pull an image right from here and run container. And thereafter, we'll create our own image and then run container and see the difference. I already opened a terminal. So I'm
Sir,
going,
when you're trying to pull an image, how do we know that what are the contents of that particular image?
so again, it's based on experience, we need to pull the right to image. So if you are a data scientist, you know that it is Anaconda that you require, right? So there will be various millions of images. So the Anaconda is the most frequent one that we use. On top of this, we can keep adding it. So just like the way we installed Anaconda in our machine and start adding modules, right? Similar to that, we are going to use this sort of images. This one is a sample one.
In the Docker Hub, what we need to search the image, just like that.
Yeah, so we have seen it, right? How to search it. Just go here, Anaconda. If you know the complete name, search for it. Search for with the same name. It's just a
Yeah,
name
got it.
that is going to pull automatically. And so if you, let's take that I want to run Nginx, sorry, Nginx. Nginx is basically a web server. I'm going to pull it, Docker pull. It's going to pull the image. You can see start downloading it, right? Around 40 MB. Okay, once it pull, you can see it in Docker images list. So forget about the remaining options. Like you can see, let me remove sound 4. Let me clean up in your case, you may not get all this stuff unless you already worked on this one. Right. So everything is clean. Still I have, okay, we have Nginx now. So we can run the container, Docker run, and we want to run it in background. Suppose if if I execute this command, if I don't add this dash D flag, what happens is it's going to run, but it will not give the next prompt. So if I add this dash D, it will give me the prompt so that I can execute in other commands. So the advantage of having to run it in background is we can keep executing other commands. Otherwise, we need to open another terminal and execute other commands. So dash D and then Nginx port, I want to make it 8080 Nginx. So it is running Docker PS. It got stopped immediately because you can see that in Docker PS it will list out all the running containers, but this container started and stopped again immediately. But when it comes to if you add dash A to Docker PS, this will even show the stopped containers. In this case, it is this container has been there. Just check the logs. Um, 41. So the ID is 41. You can add the complete ID or you can add the first few characters. Um, dash P, Docker logs, short flag. Docker logs is, we don't require this. Yeah, here we have. So dash F it is. What is 410, right? 410. Not found. Why am I getting dash P again? Container name or the Docker logs. Okay, engines is not okay. So it looks like completely stopped. Even if I give something, it's not. Dash P not found. Docker entry point. Okay, so try this. So it completely stopped. There is no way that I can start. So you need to embed this Nginx image somewhere. Okay, we'll try this one. So I'm going to create a Docker. So not this one. Okay, Docker test. Looks like I have a Docker file. Let me check that one. Open for here HTTP, and I'm going to run this. So I'm going to move this HT index.html file, which is just to displace the image. Like there's a testing Docker file creation. That's all. It's going to move to this location so that this website, basically this like this kind of web server, this will host the application. So let me run that. So Docker images. Okay, that's fine. Appears. Okay, that's also fine. Docker builds dash T. I'm going to give HTTP app dot means Docker, this Docker file location, right? You need to make sure this where the Docker file location is in. Right now, this is in Docker test itself, so I'm going to mention dot. What the hell is going on? Here's the Docker about dash T. Looks like I need to mention web app. Yeah. So it conflicts with the this one. That's the reason. Now it is we got the image Docker images. Now we got a web app. That's the name that I've given. You can give any name you want, and then you can start running this. So I can give any name again we want. So this not to be the same as the image name. You can give anything you want. And apart from it, you need to add the port number. The port number, if I mention 8080, which means the C is going to be the port number inside the Linux OS. So every Docker container is an OS, right? Mini OS. It's going to be inside the port number inside the OS, whereas this one is outside. So if I want to access from host machine, that is Windows machine in this case, I can give whatever the port number that I want, as long as it is conflict with other port number. So in this case, if I want to give 885, I can give it. Because I'm not running any application that runs with port number 8085. And apart from it, so we need to mention the image name. So image, I'm going to mention the ID 02B. That is the one. Enter. So it is running. Let's check the Docker PS. It is running and is not stopped, because this run contain is can able to run continuously without any interruption. You can see that 00008085, right? We can open an application localhost 8085. You can see that whatever that I have it in the index.html, it's supporting. In fact, this output is coming right from the container. It doesn't matter where you take these files, it is going to work, because it will have its own mini OS. Apart from it will have its own application OS related packages. This completely runs on OS packages, so this is fine. Now we will see the actual machine learning related stuff. Okay, so we know how to generate pickle file from the template, right? I'm going to use this first previous pickle file, the same one that we have used in template demo phase. So I'm not changing this. So I'm going to use the same pickle file. When I'm going to create another .py file, this is going to be the Flask API file. What this does is, so it's going to, if you look at this one, this is going to import this house prices file. House prices pickle file. So house prices pickle file, you can see that it is going to get copied here. So how do we know that it is being copied here? When you look at this Docker file, that is how I have mentioned. So the .flask demo, this file, this folder, whatever the files that I have, I want to copy right here. So even the pickle file, this model pickle file is going to sit inside this one. So based on this, I have given a path like this. And usually the pickle files are going to be binary, so I'm going to mention RB. And this is going to load the model. Okay. And this Flask, we need to create a Flask app by having like this. So we need to import a Flask app. Again, it is going to be part of requirements.txt file. Requirements.txt file, it I have already included. So how do we know that it has been installed in mini OS, that Linux OS? I've included that here, right? It's going to install the Flask API so that this is going to run. And I've created two API routes. One is predict, another one is predict file. So one is for one line input, another one is for multi batch. I mean to say you can give multiple inputs. For example, in this case, I get multiple inputs. So how do we know that this is the input that we have to have? While training, we need to cross-check how many columns this model finally had. So I have applied random forest embedded features that it got 4 columns. So I have given the same order. In fact, I got it, I copied from the input data itself. So you need to give the appropriate input and in a right manner. So I have given multiple inputs here, whereas this will work for multiple inputs. It's going to take the whole file. Whereas in this case, it's going to take a single input. I have created test.py wherein you can test both the cases. One, for a single input, I can see that I have given input here, but this is single input. You can uncomment this and execute this one. For batch one, I have created another one. You can see that it is this part you need to enable it. So when you enable this one, you need to disable this. When you enable this one, you need to disable this by commenting out. And this 3000 port, I got it from, you can see that I am running under 3000 port. Where do I get this 3000? In this, I have mentioned 3000. If you give some other port number, so let's say 3050, you need to change even in Docker file. Here, these two places you need to change. Okay. You need to give the same port number all the time. Otherwise, it's not going to work. Initially this is going to be a bit confusing, but go through the files, you will clearly understand. So it's not really a difficult one. So this is all about how can we deploy it in real time. How can deploy the model in real time and create an API so that web developers can take it and start embedding in their applications. We are not going to build the application, front end and back end, we are not going to build it. But we are going to expose this model as an API. So that is when this Flask comes in. That is why we have created two routes. So what these two routes are all about? If you look at this test.py, this is the base one. See, I'm running in local machine. If you are running in some other server, you need to change that to the domain name or server name. And it is adding /predict to route to single user function, single line function, and it is adding /predict file. So finally, it's going to be for single line, it's going to be /predict URL. If it is multiple batch file, it's going to be /predict file, something like that, right? And let's test it. Okay, let me explain this part. So we are taking the input from this test.py. So we are sending the request. And when we send the request, and it's going to be, we need to catch it using request.args.get. We can't directly get the ID column. Okay, so whenever we click on this, whenever we execute this one and send a request post, from post, like whatever the data that we get, we need to catch it using request.args.get. Where do we got this request.args? Request, we got it, and in this one, actually part of class, we need to find out the args and get and the column name. Suppose if the model has 10 columns, we need to provide the complete column list. And you need to change this test.py column list. And you need to provide the appropriate input. And if it is batch file, you need to provide the appropriate input, appropriate set of inputs, right? So here we need to catch the inputs, whatever we have fed it through this. So it's going to catch 17856, 1710 for the respective columns. And then it's going to form an array, and then it's going to feed to predict. This is going to give us the results. This is going to return the error, return the result, predicted result. If at all this get any error, is going to give us error prediction. So first save to be in a safer side. The same way, here we are trying to catch a whole file. We are trying to send input underscore file.csv, the whole file. Then we are going to catch in this manner the files, not args. If it is single one, it's going to be args. If it is files, it's going to be files. And moreover, method got changed. If you want to send a file, then you need to change the method, mention the method post. Whereas if you don't mention anything, then it's going to be for single input, it's going to be get. You don't need to mention it because that's the default one. Okay. Then we are going to feed this input data directly to this one. We can feed it. You can see that I have read read CSV. This is going to form a data frame, and I made sure that header none. If in case we provide any headers to it, then we need to mention headers. I mean, we can ignore this part. By default, the first row is going to consider as a header column. So the typical way of reading the data frame. Then we need to feed this input data to model.predict so that it's going to list out the predictions and it's going to return it. Let me run this one. I have clearly given the instructions in commands.txt how to run this one. Let me copy this. Let me cross-check any file that are running. I don't have any, okay, Docker images. Okay, I don't have any thing running right now on this. Copy. And based on this Docker file, okay, is going to install all the OS related packages. Apart from it, it is going to make sure that this is the working directory, and will copy all the files. Initially, there won't be any folder called predict API, class predict API. What it does is when we mention working directory, this one, it will have only this part because of this Anaconda 3, and in Linux usually have this one. So when we mention working directory, it's going to create a directory under this one. And it's going to copy all the files. You can see WSGO files and all the files, .py, pickle file, requirements.txt file. It's going to copy here. I'll explain what is WSGI, and then it's going to install all the packages, Python packages right under whatever the package that is being listed in requirements.txt. And then this part is related to WSGI. So WSGI is basically a more safer way to start an application. This will have two things. One, it will tell us, and look, it will tell to the web server where the application files are, where the Python files are, where the Python binary by itself running. You can see 3.12, right? And how to start the application. This is where the application has to start. From here onwards, it's going to start the application. It's going to execute this part. Okay, let me execute this one. And WSGI file is going to is a more safer way to start an application, right? And it's more safer way to mention where the binaries are all in a centralized location. This is one. Docker file is going to have this. We need this one to run this WSGI under this port number 3000. So I already told you that 3000, you need to make change according to the port number that you have mentioned here. Okay, let me go to commands and execute this. Let's build the image, Docker image. uh, Fail to solve, fail to read Docker file because I'm in class demo. So I'm mentioning Docker, Docker file is in current directory. In fact, I don't have a Docker file, right? I have in the parent directory. Let me cross check whether I have Docker file or not. You can see Docker file here. Okay, I can run this command, Docker build class predict. It is building Docker image. It has built the Docker image. Let's cross check it. Docker images. You can see Flask predict API, right? So how it got this name? Because that's the name that I given in Docker build, right? You can give any name you want as long as it's not conflict in nature. So if there is another image that runs with the same name, give something like 1 or 2, whatever. Okay. We have image. Now it's like a image like a blueprint. Now we need to run the container. Okay. Whenever you run the containers, you can see the image name. I have given the image name, and internally it's running under 3000 port because I have given 3000 port. If it's something else, then you need to change accordingly. So let's say 3050, you have given it here. Make changes to here 3050 and 3050. Build the image, and then when you run the container, you need to mention 3050 here. You can give any port number here because this is related to host machine. Make sure that you don't have any other uh, service or app running in the same port number. Right now in my machine, there's no app that is running in 3000 port number. If at all there is one, it is going to give an error. So going to run the container, Docker PS. So we have the container running. How do you make sure that it is running? You can see that this web app. Okay, sorry, this is not web app, this one. Okay, let me stop the other one because it's getting confused. Docker RM F7. So whenever you want to remove a container, you need to stop this first. This F7 is the ID. So I want to stop this one. You can give the complete ID or the first few characters. Suppose if another container runs with the same F734 instead of F724, then you should not give F7. You have to give 34. Basically, as long as it's unique, it's going to work. Here, there is no container that is running, starts with F7, right? Then it's fine. So I'm going to remove the container. Docker PS, the container is very well running. Now we can go to class demo where I have this test.py. I can start running it. Let me open this test.py. Let's start with a single line input. Okay. Let me comment this out too. And python.test.py is the way to run the Python file. You can see that you got the output. Let me change the input. Let's take 988. Okay. It will give a different output. You can see it start predicting it. The model is predicting and giving us the output. You can see that this change, isn't it? So with this input, the house price is going to be this one. The previous one is going to be this one. This is only for single line. What if I want to send multiple inputs? You need to include in some CSV or some other way, and you need to change the code accordingly in flask.api. Okay, and then you need to run this. Like, let me go to test.py, comment this part. Let me uncomment this. So right now, this input file is in my parent directory. So I'm going dot means parent directory, not in Flask demo. That's the reason I have mentioned dot. Or else you can give the hard path, hardcore, and you can hardcode the path, complete path. You can give the complete this path, right? So let me run this Python test.py. You can see that for every input that you mentioned, you got an output. There are some duplicates too I have added. You can see that the same output you got because I have added duplicate inputs. The same 461 you can see, right? That's the reason. Even if you change slightly, let me change it, like then it's going to change. Mix with this again. You can see 241,868, 241,868, but 635814, 63581420. Okay, so for the same one, it is giving, it's not affecting it. All right, so we'll do one thing. We'll change it somewhere else. Let's take 4. But this one is 832, the same row, and 834. So let me try this one now. I think 241868638. Looks like it is giving the same output. Same, it's predicting the same thing. Let me give a drastically different value. 1834. Now I think this got changed. 24168. Right? How many rows after that? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Yeah, this one. This got changed. Okay, this is the real, this is the way that we can create an API. In deployment, we'll have another session on how to deploy it, but this regression template, right? But this course is based on generative AI. So we are going to deploy a generative AI application. Consider this as a mini project. I mean to say, mini deployment project, but it runs in our own local machine. Of course, we can install, deploy it in Azure. You can ignore these files, but this is basically this manifest files also. This related deployment, I deployed in Azure for the previous batch. But this generative AI course, we're going to take a generative AI solution and deploy it in production and see how it's going to be hosted. Okay. Any questions? Unless you try this thing, it's difficult to understand. But the explanation, I have given almost everything, like all the files. This input file is for batch 1. WSGI is the centralized location where it will have all the files locations and where to start the application. Docker file is going to have like a blueprint to create an image. And I have already explained this part. A command is going to list out all the commands that unit executes. I already listed. So this is going, you should not push this commands.txt. And this is later Azure deployment. You can ignore it because we are going to deploy a generative AI solution. Again, these two files, manifest files, you can ignore it. This led to Kubernetes. We are going to create a cluster. We're going to run multiple containers to load balance it. So this related to Kubernetes cluster, you can ignore this. This is not necessary for local machine. Test.py is to test the API. And this requirements.txt will have all the Python packages. This is the actual model file, and this is the API file, Flask API file. This will have two routes, write and write file. This for single input, and this for multiple inputs. I already explained this code, right? This is the way we load the data. We load the model. This we were going to use this one. All. Any questions?
Sir, that pickle file is that binary file, sir. That one.
Yeah, we have already seen it in regression template demo phase, right? The model is going to pickle it, pickle dot save. Do you remember it in template? Go back to the template, regression template. At the end, we have saved the model, right?
Yes, sir.
That's
That
going to be
previous
binary file. Yeah, that's going to be a binary file. You need to consider as binary file. That's the reason you need to read it as RB, not simply R. In fact, I tested with R, it didn't work. Then later I changed to RB. It's not working. All right. That's it for today. Practice this one. This is a very important one. You can ignore these files, Azure pipelines and manifest folder, the complete folder, deployment and service file. And we're going to see a end-to-end deployment on generative AI solution after completing LangChain.
What is R and RB?
Your voice is breaking. Go ahead. R
What
and
if is there any difference between RB and R?
if it is a normal file, we can use R to read it. Whereas if it is a binary file, you're going to use RB. Like this pickle file or some elastic.bin file. Those files you can't read with small r, just with R. You need to mention B also. Again, not to bother too much about this. So again, we can trial and error. So if you get an error, even we have not included it, I directly read the data, and then I got an error. So when I searched online, it's saying that it's a binary file. So read it as RB. Then based on that, I got this one. Yeah. Any questions?
So in the Docker file is there, right? So
Hmm.
is the same code for everything?
This is for regression. So I'm going to use Anaconda, but in generative AI, it's going to change. So I may have different application OS dependencies. I may have different completely different requirements.txt file. So things will change. Usually when it comes to AI, almost all the cases we use Anaconda 3 unless we have better option.
So what is that requirement text? There is like Flask, I understood about that one. After that one, mod WSGI.
Yeah, WSGI is like a more secure way to give all the centralized files location, both application and Python related, and Python exe by itself, and way to start the application. If this is in production, this is what we use. We call it as web server gateway interface. If we directly
Security
feed,
purpose.
yeah, if you directly feed it here, then it's going to create security problems. This is going to be more secure, and we mention it in WSGI.
Okay.
Requirements.txt, as I told you that all the Python packages that we need, we need to mention it here. I think yesterday we have seen how to create virtual environment, right?
No.
Okay, so usually we create virtual environment like this. Want to create /-n, the virtual environment, and then you can mention let's take Python. Let's take 3. I want to run with Python 3.10. So it's going to create a virtual environment like this. Let me execute this one. Okay, let's do this one. It's going to create a virtual environment. But in this case, I have not created in virtual environment because it is going to be mini OS. We don't require it. Usually we're going to create like this. Conda activate the virtual environment. We'll see another virtual environment later. So this is how we can create it. But in this case, we don't require it. We need to mention all the Python libraries in this requirements.txt, wherein it's going to install inside that container. So when the application start working, then we don't have any, no. When we import something, we need to have these libraries, right? Otherwise, we're going to get no module name. This NumPy, Pandas, Traceback, Pickle will come with Anaconda itself. So we don't want to import it. Any other questions?
Yeah, it's kind of hard to understand the
Yeah.
codes.
So initially it's difficult to understand. Go to the video, prepare the notes, try to practice it. Then it's going to be quite easy. And it's not easy to prepare this one. It takes time. And even if you, okay, so we'll see that later. So how to prepare this API itself. Right now you can take it as a base and we can simply use generative AI solution. Create an Flask API that takes a machine learning model. So it's giving me the whole structure. So you can see that it's reading it. You can start, predicting it. Here I have used predict. I can add another one, batch one. Create 2 routes with one online out that is /predict, another one for batch file that comes from .csv. This is going to create a /batch predict also. is going to read a file, the whole file, and start predicting it. So we can do that. Again, it depends on like experience. So you can use generative AI. It's much more handy. If you do 2 to 3 projects, then you will understand it quite. It's not really difficult. All right. Any other questions?
No.
That's it for today. Practice this one. There's an important one. So don't skip this one. Tomorrow is a Friday. Tomorrow is Thursday, right? We will have our next session on Friday, Langchain one. You can skip tomorrow, so practice this one. It may take a day or two. So practice this. By Friday, prepare, no, at least execute this one once and make sure that it is up and running. Okay, I'll provide all the files. I already provided in this one. Detection model deployment. One change you need to make here is I forgot to add this /var/ this part. This may be like this. Please add this one. So I already commented this part. Let's copy this one. This has to be in this location, not anywhere else. Okay. If at all that has been missed, add this ones. This has to be in this location. Okay, that's all. Thanks for joining.
Yeah, sir, installation video, sir, you have, sir, uploaded that
Installation?
video. That
Installation
yesterday.
video. Already uploaded it, right? So databases, installation video.
Oh, okay.